Welcome, strategists, to this explainer. Think of the Cambridge mathematics exams, whether you're looking at syllabus codes 0580, 0606, 4024, 4037, or 4040, not as massive, terrifying obstacles, but as a battlefield. And you're a warrior. We're taking an ancient warrior wisdom approach to modern exam strategy today. I see two types of students all the time. Let's call them Alex and Sam. Alex overloads with raw mathematics facts, just vomits numbers onto the page with absolutely zero analysis. And Sam? Well, Sam rushes. Sam completely misses the command word requirements. They both end up with a sea of red pen marks on their past papers. But today, we're going to learn how to slice through these complex questions with absolute surgical precision. We are going to master this playbook.
Okay, let's dive into this. Here's our exact roadmap to conquering this vast syllabus. We'll cover the exam arena, essential prior knowledge, and decoding command words. Then we'll get into tactics for differentiation and modulus, followed by tactics for permutations and combinations. Finally, we'll wrap up with the winning revision strategy. Let's get moving.
Section 1. The Cambridge Exam Arena. Understanding the battlefield.
Every great warrior knows the terrain, right? Well, this assessment is perfectly balanced. 2 papers, exactly 2 hours each, carrying an identical 50% weight of your final grade. Paper 1 is non-calculator. Paper 2 allows a calculator. Listen to me. This means they require entirely different strategic approaches. It's a time management matrix. You literally can't just cram for paper 1 and expect to survive. I've seen students completely fail their pacing by trying to manually calculate complex fractions that should have been simplified algebraically first. And on the flip side, you can't rush paper 2, relying so heavily on your calculator that you forget to write down your intermediary steps. The examiner needs to see your thought process. If you just write down the final answer your calculator spat out, you're throwing away easy marks. Respect the balance of this arena.
Section 2. Essential prior knowledge. Building the foundation.
Okay, advanced tactics will absolutely fail if your basic stance is weak. The syllabus assumes you are perfectly fluent in foundational algebra. We are talking about working with expressions and formulae, linear and quadratic factorization, solving simultaneous equations, working with inequalities, and plotting and sketching graphs. This fluency? It's the non-negotiable entry fee for advanced mathematics. If you are stuttering on expanding brackets or stumbling over a basic quadratic equation, it becomes incredibly difficult to execute advanced tactics like differentiating a complex polynomial later on. You have to lock these basics down so tightly that they become pure muscle memory.
Section 3. Decoding exam command words. The examiner's secret language.
This is where we talk about Sam. Remember Sam? Rushing, missing the point. Command words are the secret vocabulary examiners use to tell you exactly how to score marks. Differing command words demand completely different types of written responses. When you see words like calculate or state, the path is straightforward. Just do the math. But look closely at show that and explain. If a question says show that the area is 24 and you just write area equals 24, you get 0. You miss the marks. You must provide structured evidence leading to that result. Top strategists use the Peel framework here. Point, evidence, explanation, link. Your point is identifying the correct formula. Your evidence is substituting the specific values. The explanation is your step-by-step algebraic working, and the link explicitly states the final result in the exact format the examiner requested. That is how you secure 100% of the mark potential. Before we continue, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 4. Tactics for differentiation and modulus. Executing the strategy. We are now shifting from macro-level rules to micro-level execution. This is where Alex messes up, overloading answers with facts but no logical structure. Complex calculus problems, like finding tangents and normals, break down into an infallible 3-step execution. Watch those red pen marks transform into green check marks when you do this. Step 1. Differentiate the function to find the gradient of the curve. Step 2. Substitute your given x value to identify the specific gradient of the tangent at that point. Step 3. Here is the key tactical maneuver. To find the normal, which is the line perfectly perpendicular to the tangent, you use the rule m1 times m2 equals -1. By systematically moving through these exact steps, you format your answer with clear evidence and logical progression. No more chaotic math vomiting, just clean, samurai-like precision. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's treat this like an interactive workshop. Let's do a quick data scan challenge. Look at this question. If the value of x increases by 0.001, what is the corresponding approximate increase in y? Without a strategy, a student might panic, try to plug complex decimals to high powers into a calculator, and completely mess up the syntax. But listen, the gradient at a specific point is actually the key to calculating this approximate change. You simply take your gradient and multiply it by that small change in x. It's that simple. If your gradient is 19 and the change in x is 0.0001, the change in y is approximately 0.0019. It is a clean, simple, and completely error-free multiplication. You slice right through the confusion.
Let's turn to the modulus function. Time for another challenge. Let's find the flaw in how people think about this. The crucial point here is understanding exactly what this function does. Defined by these straight vertical bars, it simply asks for the magnitude. That means the positive value of a number, completely regardless of its original sign. The modulus of 28 is 28. The modulus of -28, it's also 28. The flaw students make is thinking the modulus operation somehow changes positive numbers to negative. It doesn't. It forces everything to be positive. It's an absolute value.
So what is the visual consequence of this? Imagine doing a speed writing test where you have to sketch y equals the modulus of f of x. Think of the x-axis as a perfect, unbreakable mirror. Any part of the curve that dips below the x-axis, where y is negative, is reflected perfectly upwards. It literally flips those negative valleys into positive peaks. Creating this mental image, this visual cheat sheet, is a powerful tactical tool during a high-pressure exam. You don't even have to calculate every point. You just reflect the negative space up. Boom. Done.
Section 5. Tactics for permutations and combinations. Arrangement versus selection. We are now tackling one of the most notoriously tricky parts of the syllabus. Students bleed marks here. They hemorrhage them because they fundamentally confuse the two concepts. But let's frame this as a simple battle of definitions. Permutations, NPR, are for arrangements where the order strictly matters. Think of a combination lock, which ironically should be called a permutation lock. The sequence of numbers is absolutely essential. Or think about arranging letters to form a password. Combinations, NCR, are for selections where the order does not matter at all. Think of simply selecting a group or a team of people. If you pick Sarah, then Jane, it's the exact same team as picking Jane, then Sarah. Knowing this fundamental distinction protects your marks. Order matters, permutation. Order doesn't matter, combination. Lock that into your brain.
Section 6. The winning revision strategy. Mathematics in nature.
Okay, we've executed the tactics and assembled the final system. We know the 3 rules that guarantee top marks. 1. Command word decoding. 2. Peel framework application. 3. The time management matrix of the 2 papers. But remember, while the exam is a strategic game we play, mathematics itself is not just a test on a piece of paper. Consider the sequence on the screen. 0, 1, 1, 2, 3, 5, 8. This is the start of the famous Fibonacci sequence, where each number is the sum of the preceding 2 numbers. It's a beautiful, infinite pattern. Now, before we look at what this means for the real world, listen up. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to AceTheExams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.
So why does Fibonacci matter? Because it dictates the spirals of pine cones, the arrangement of leaves on a stem, the way a fern uncurls, and even the shape of entire galaxies. When you study Cambridge mathematics, you aren't just learning how to pass a paper. You are literally learning the structural code of the universe. It's the ultimate playbook. So strategists, as you step out of the exam arena and look at the world around you today, what other hidden mathematical structures do you think dictate the natural world? Keep questioning, keep strategizing, and enjoy the incredible journey of mastering this game